Okay, this is the number 6 review, first semester Algebra 2. This is going to be the B part because I couldn't finish it all in the 15 minutes. We're continuing. I just want to go over factoring to solve quadratic equations and connecting that to the intercept form for graphing quadratic equations. So we were at 2x squared plus 14x plus 24 equals 0. We can see the 2, the 14, and 24 have a common factor of 2, which leaves you with x squared plus 7x plus 12. If we simply look at x squared plus 7x plus 12, we can use guess and check to factor x plus 3 times x plus 4. And we check that with FOIL, x times x squared, outside 4 times x, 4x, inside 3 times x, 3x, which gives you 7x, and 3 times 4 is 12. So that's the last term. The only difference from just factoring is that it is equal to 0. So we want to solve using the zero product property, because remember, a solution, write this down, the solutions are either can be called the x-intercepts, they're the roots or real roots. So the x-intercepts, this is going to be your p-value here, based on this y equals a times x minus p times x minus q. This is going to be your q-value here, but since it's x minus p, and this is x plus 3, and then p is negative 3, x minus q, and this is x plus 4, q equals negative 4. You want to know what will give you 0, because remember, 0 and y can be used interchangeably. That's right here, 0 and y can be used interchangeably. So we now take the 0, and over here we would have made it a y to find the y value, but I just have to know that this is my y value right here, the 0 value. So if I make either one of these factors, x plus 3 or x plus 4, 0, then the whole thing becomes 0 using the zero product property. So here it would be negative 3, here it would be negative 4. They're not always that simple. So if you say x plus 3, what would x have to be in x plus 3 to equal 0? Subtract 3 from both sides, x would equal negative 3. If you said in the second factor, what would x have to be in x plus 4 to equal 0? You subtract 4 from both sides, x would equal negative 4. Okay, we already knew that from up here, but this is another way to actually figure that out. So we graph it, and you had negative 3, 0, and negative 4, 0. Right in the middle of that was the axis of symmetry, which was negative 7/2 or negative 3.5. Then we needed to find the vertex, so we just simply plugged in that negative 3.5 like we talked about in the other video or in the other recording. And that's done right here. Y equals 2 times negative 3.5 plus 3. You're just plugging into this equation right here. Or, excuse me, this equation right here. 2 times x plus 3 times x plus 4. And then negative 3.5 substituted for x plus 4. So y equals 2 times negative 5/10. Negative 3.5 plus 3 is negative 5/10. Negative 3 and 5/10 plus 4 is 5/10. Again, we multiplied 5/10 and negative 5/10, got negative 25/100. If we take that 2 times, that gives us negative 5.0 or negative 5/10, which is negative 1/2. So I just converted them to fractions. So you have negative 7/2, negative 1/2 being the vertex. So you have the vertex, you have your 2 intercepts, now you need 2 more points. You probably could have picked the point negative 1, maybe even 0. I think 0 would have put us up at 12. It's not too far off the graph, so it would have been okay. I went ahead and picked negative 2, which is right here, not very far from the axis of symmetry, 1.5 to be exact. So I plugged in negative 2 to this equation, 2 times x plus 3 times x plus 4. So it would have been y equals 2 times negative 2 plus 3 times negative 2 plus 4. Then 2 times 1 times 2. So 2 times 1 is 2, times another 2 is 4, so y equals 4. So negative 2, 4 is here. And again, it's 1.5 from the axis of symmetry. Go 1.5 the other way, and it's negative 5, 4. I'm going to have you try the next one on your own, and then you'll turn the recording back on and see how you did. Okay, you have your problem 12r squared plus 44r plus 24 equals 0. And you are going to be factoring that, and then you'll get this form. I know it'll still say 0, but it'll be this basic form, 0 or y, they're interchangeable, equals a times, in parentheses, x minus p times, in parentheses, x minus q. So go ahead and factor it. You're going to have to use AC method on this one. you're going to set up the graphing. Let me show you the steps on that. So there are your steps, and you can just leave this on and look at it. Just pause the video. You need to have the axis of symmetry, the vertex, the x-intercepts, then you need to find one point and reflect it, and then you'll end up with 5 points on your graph. You can use your graph paper there, or you can use the graph paper you've been given from school, or you can go ahead and download graphs to graph this. Turn the video on again and check your answers when you're finished. Okay, on this problem, 12r squared plus 44r plus 24 equals 0, I'm sure you found yourself having a little bit of struggle when we got over to the graphing. So let's go ahead and go through the factoring first, because that's the important part. The graphing is just to make the connection between the intercept form. That's what this is right here. This is the intercept form of a quadratic equation, and then it can be graphed from the intercept form. So you first of all factored out a common 4, so 4 times 3r squared plus 11r plus 6 equals 0. We're going to go ahead and use this right here as we are factoring the 3r squared plus 11r plus 6. So using the AC method, our A is 3, our B is 11, and our C is 6. AC is 3 times 6, which equals 18, and then B. So remember, it's an AC and then B. B is 11. You want to know what factors of 18 will give you 11. Well, 6 and 3 would only give you 9. 18 and 1 would give you 19. So that leaves 9 and 2. 9 times 2 is 18. And 9 plus 2 is 11. Add on your r's. 9r plus 2r equals 11r. Bring down your first term. Make sure you're going from the factored out problem. Bring down your 3r squared. Bring down your 6. Bring down your middle term. 9r and 2r. You could do it either way, but I preferred to put the 9r with the 3r squared and the 2r with the 6. Then you put those in parentheses using the grouping method. Make sure you make it equal to 0 because this is an equation. And then bring down that 4 out in front. Now that you've grouped, you're going to factor out the distributive property from 3r squared plus 9r. The common factor is 3r. So you factor out a 3r. 3r times what is 3r squared? Well, that's r. 3r times what is 9r? Well, that's 3. So you have r plus 3. Now you know over here you're going to have, in the second factoring, you're going to have r plus 3 as well, because that's one of your sides, one of your factors. So then you say r times what gives you 2r? Well, that's 2. And then you check it with the 6. Is 2 times 3 6? Yes, it is. So you've correctly factored. So you bring down your r plus 3. That's one of your sides. You can see it in your check. Your 3r and your 2 is your other side. And then you bring down your 4 and put it out in front. Make sure you set it equal to 0. This is what you will use as intercept form. You can see it comes over here. Instead of being 4 times r plus 3 times 3r plus 2 equals 0, I change that 0 to a y. So y equals 4 times, in parentheses, r plus 3 times 3r plus 2. And then we're going to finish with the factoring. You check it. So r plus 3 times 3r plus 2. 3 times r is 3r squared. 3r times 3 is 9r. 2 times r is 2r. And 2 times 3 is 6. 2r and 9r is 11r. So that matches 3r squared. 2r and 9r is 11r. It matches. 6 matches. Now, we use the zero product property to tell what our x's are. In this case, our r's will equal. And so for r plus 3, we would have known negative 3, because negative 3 plus 3 is 0. This is the zero product property. And for 3r plus 2, it's not quite as easy to know what the value of r will be to give you 0. So this is helpful to use the zero product property. 3r plus 2 equals 0. Subtract 2 from both sides. We're left with 3r equaling negative 2. Divide both sides by 3. And you're left with r equaling negative 2/3. These are your values of r for your solution. And what I really want you to take away from this is, what is the meaning of this graphically? Well, these are your intercept values. Remember, your solutions are your x-intercepts on your graph, are your roots, and are your real roots. They are all the same thing. Okay, now graphically this was a very challenging problem, but I'll take you through it. If you didn't quite figure it out, that's fine. The p was easy, so it's x minus p, r plus 3. We know it's going to be negative 3. P equals negative 3. Now this one's not so straightforward because it's 3r plus 2. You have that 3 times r, so you might be able to see how the pattern works. Q is going to equal a negative, and you have negative 2/3. You've got the 2 here, and then you would divide by 3. You can see that happening over here on using the zero product property. Again, this is not so simple to find the middle of, so this time we will need to find the midpoint of this by going p plus q divided by 2. X equals negative 3 plus negative 2/3 divided by 2. X equals negative 3 and 2/3 divided by 2. Well, that gets pretty ugly. You need to change negative 3 and 2/3 to an improper fraction, which is negative 11/3 divided by 2. Notice I rewrote it differently. When you have division with fractions, you multiply by the reciprocal. So we changed division to multiplication. 2 became 1/2 its reciprocal, which then gave us x equaling negative 11 over 3 times 1/2, which is a negative 11 over 6, which for graphing purposes is more easily written negative 1 and 5/6. So that's our x-coordinate, negative 1 and 5/6. Now, we need to find our y-coordinate. So you just simply substitute in your negative 1 and 5/6, but I'm going to use negative 11/6 because it's easier to use in the problem. So y equals 4 times negative 11/6 plus 3, we're just substituting into this problem right here, times 3 times negative 11/6 plus 2. A lot of fractions here. I know you don't like them very well, but you got to deal with them. So negative 11/6 plus 3 is the same as 18/6. 18 divided by 6 is 3. Negative 11/6 and 18/6 is 7/6. Times 4, I put a 1 under the 4 to make it a fraction. Now this one was 3 times negative 11/6, which is negative 33/6 plus 2. 2 wholes is 12/6, so plus 12/6. Negative 33/6 and 12/6 is negative 21/6, which simplifies to negative 7/2 if you divide the numerator and denominator by 3. So now we have 4 times 7/6 times negative 7/2. So 4 times 7 times negative 7 is negative 196 divided by 12. And when you do that, you end up with negative 16.3 repeating, which is actually a 0.3 repeating is negative 16 1/3. So there's your negative 16 1/3. We now needed to rename the y-axis. I went by 3's. So here's 15, here's 18, negative 16 1/3 is right here, negative 1 and 5/6, negative 16/3. Our p is negative 30, plotted that, labeled it. Our q was a little more challenging, negative 2/3, plotted and labeled that. And then you needed 2 more points. Now this is another place where it was challenging. Normally you reflect, but this time it was a big pain to reflect because you're lots of fractional amounts away from the axis. Okay, so I picked negative 1 because negative 1 and 5/6 is the axis of symmetry. So I picked negative 1 knowing it would fall somewhere in here because of where our negative 2/3 is our x-intercept. So we plug in negative 1 back into this. So y equals 4 times negative 1 plus 3 times 3 times negative 1 plus 2. Negative 1 and 3 is 2. 3 times negative 1 is negative 3 plus 2, which is negative 1. So you have 4 times 2, which is 8, times negative 1, which is negative 8. Negative 1, negative 8. Okay, so that gave me my vertex, gave me a point, 2 points to the right. I've got 1 point to the left. I need another to the left. Reflection is just not a good option in this one. That's why I put a line through it. So on the left side, I went to negative 2. Now I know it's going to be quite close because negative 1 and 5/6 is the x-coordinate of my vertex. So I put in negative 2. So it's negative 2 plus 3, which is 1. 3 times negative 2 is negative 6 plus 2 is negative 4. So I have 4 times 1 times negative 4, which is negative 16. So negative 2, negative 16, which is right here. That is your ordered pair for that. Very challenging, but allows you again to see the relationship between factoring and graphing using the intercept form. Hope this has been helpful for you.